Hello friends, welcome to our channel. I hope you are all good and you are studying with your full focus. Thank you for joining me today. Today we are going to solve question number 17 from the chapter from the exercise 3.2 of the chapter theorems related to circles. Question number 17 1, it says two equal circles of radius 10 cm intersect each other and the length of their common chord is 12 cm. Find the distance between the centers. So this is our question. Two equal circles. Center P and Q. They intersect each other, let us say at points A and B. We have to find out, and the radius is given. Radius is 10 centimeters. And the length of their common chord, that means chord OA, it is given. It is 12 centimeter. We have to find out the distance between their centers. Now, sorry, this length is actually AB. This is B. Length BA equal to 12 centimeter. It is given. We know from application 13, we have done it in our previous video. If two circles intersect each other at 2 points, then their centers will lie on the perpendicular bisector of their common chord. So in this case, the common chord is AB. So their centers will lie on the perpendicular bisector. That means this is the perpendicular bisector. Okay, lie on the perpendicular bisector of their common chord. So PQ is the perpendicular bisector of AB. Therefore, we can say PQ is perpendicular bisector of AB. Therefore, let us call this point O. Therefore, OA is equal to half of AB. This is 6 centimeter. So AO is 6 centimeter, and it is given that the radius is 10 centimeter. That means PA is 10 centimeter. Therefore, in triangle AOP, hypotenuse square is equal to perpendicular square. That means PA square is equal to OA square plus PO square. So 10 square is equal to 6 square plus PO square. So PO is equal to 8 centimeter. Now, if we join AQ, we can prove uh, triangle AOP is congruent to triangle AOQ. Therefore, PO equal to OP. Sorry, PO equal to OQ. Therefore, we can say PQ is equal to, that means 2 into 8, that means 16 centimeter. So this is our answer. Now, question number 2. I hope question number 1 I hope question number 1 is clear to you. Now question number 2. Question number 2 says AB and AC are two equal chords of a circle with radius or 5 centimeter. The center is outside the triangle ABC. AB equal to AC equal to 6 centimeter. Then find BC. Now let us see the diagram. So this is our diagram. This is a circle with center O. AB and AC are two equal chords with length 6 centimeter, and center O is outside the triangle ABC. It is given that the radius, that means OB, is 5 centimeter. Now let us draw a perpendicular BP on BC. BP is a perpendicular on, sorry, OP is a perpendicular on BC. Okay. OP is a OP is a perpendicular on BC. Therefore, OP bisects BC. Therefore, BP equal to PC. Now now so this part is equal to this part. Now we can say triangle APB is congruent to triangle APC. This side is equal to this side is equal to this side, and this is our common side. Therefore, angle APB is 90 degree. Okay, this is a straight line, that means the total angle is 180 degree. So 180 when divided by 2 is 90. So this angle is 90 degree. APB is 90 degree. Therefore, let us assume, let OP is equal to the length OP is equal to R. OP is equal to R. This part is R. Now OA is a radius. Therefore, the total OA is actually 5. So this part will be 5 minus R. AP part will be 5 minus R centimeter. If OP is R, then this part will be 5 minus R. And BP is equal to, let us say this is X. BP equal to X centimeter. Now in triangle ABP, we can say hypotenuse square is equal to perpendicular square plus base square. So AB is 6, it is given. BP is X square. AP is 5 minus R square. And in triangle, this triangle OPB, hypotenuse square equal to perpendicular square plus base square. Now we have these two equations, equation 1 and 2. If we solve them, we are going to get the value of x. Now, from this equation, the value of x square is 36 minus this quantity. This is the value of x square, and from this equation, the value of x square is 25 minus r square. So this is what we are getting. Okay, these are the values of x square. Now, let us transfer 25 to the left side and transfer this quantity to the right side. A square minus b square, that means a plus b, a minus b. So this is 11 by 5 equal to 5 minus 2r. So 2r is equal to 5 minus 11 by 5. (14 by 5). Now if we cancel 2, if we divide both sides by 2, we are getting 7 by 5. So r is equal to 7 by 5 centimeter. Now from equation 2, we can write 25 equal to x square plus r square, that means 49 by 25. So x square is equal to so it is so the value of x we are getting is 24 by 5. Now we know BC equal to 2 into x. Therefore we can say BC is equal to 48 by 5 centimeter, which is equal to 9.6 centimeter. Okay, so this is our answer, 9.6 centimeter. Now let us do next question. Question number 3 says, we have a circle with center O and two chords AB and CD are equal in length, which is equal to 6 centimeter, and angle AOB is 60 degree. Now we need to find out R, radius. So the AB is 6 centimeter. In triangle AOB we can say OA equal to OB, because they are the radius of same circle. OA equal to OB. So this angle should be equal to this angle. So angle OAB is equal to angle OBA. Now angle AOB plus OAB plus angle OBA is 180 degree. So AOB is given. So OAB plus angle so we can say OAB plus OBA equal to 180 minus 60, that means 120 degree. But these two angles are equal. Okay, these two angles are equal. Why? Because OAB is an isosceles triangle. Therefore we can say each angle is equal to 60 degree. Therefore we observe that AOB equal to OAB equal to OBA, which are all 60 degree. So the triangle is equilateral triangle. Therefore angle OAB, triangle OAB is equilateral. Therefore we can say OB, that means we can say the radius is also 6 centimeter. I hope this thing is clear to you. Now let us proceed to next question. Question number 4 says P is any point in a circle with center O if the length of the radius is 5 centimeter and OP is equal to 3 centimeter, then let us determine the least length of the chord passing through the point P. Let us see the diagram. So this is our diagram where we can see this is a circle with center O and this is a point P. Okay, this is a point P. Inside the circle, and now we know that through a point P inside a circle many chords can be drawn. So we need to find out the length of the shortest chord. So among many chords, only one chord will be the shortest, which will be perpendicular to the line OP. Okay, so through the point P, if we draw many chords, among those chords only one chord will be the shortest, and that chord must make a right angle with OP. So AB is shortest when OP is perpendicular to AB. So let us write it. AB is shortest when OP is perpendicular to AB. Now OP is perpendicular to AB, that means therefore OP bisects AB. Therefore AP is equal to half of, or we can say 2AP is equal to AB. Now in triangle OPA, OA square hypotenuse square equal to perpendicular square plus base square. So OA square equal to 5 square, OP square equal to 3 square plus AP square equal to AP is equal to root over 5 square minus 3 square. That means AP is equal to 4. So AP is 4 centimeter. Therefore we can say AB will be 2 into 4 centimeter. That means 8 centimeter. So the length of AB will be, the length of shortest chord will be 8 centimeter. Question number 5 says two circles with their centers P and Q intersect each other at points A and B. Through the point A, a straight line parallel to PQ intersects the two circles at points C and D respectively. If PQ equal to 5 centimeter, then let us determine the length of CD. We know that when two circles intersect at 2 points and a line passes through any one of the points of intersection, either A or B, and a line passes through any one of the points of intersection and which is parallel to the line joining the centers, then the length of the first line, that means CD, will be twice that of the second line. That means CD should be twice, the length of CD should be twice that of PQ. We have proved it in this exercise. Therefore we can say CD should be twice of PQ. So it is 10 centimeter. So our chapter theorems related to circle is completed. In our next video we are going to start the chapter rectangular parallelopipeds or cuboids. We are going to solve that chapter. That's all for today, students. If you liked my video and if you are getting some help from my work, please like, share and subscribe to my channel. Your one subscription will be a great motivation for me. And if you have any doubt or any question, please leave that below in the comment section. I shall try to answer them. Thank you, friends.